Hi guys, today we're going to continue this part of the unit where we're graphing quadratic functions. And today we're going to take a look at factors. We talked a little bit about what they meant when we find the factors or the x-intercepts or the solutions. And I believe we also called them the zeros. What does that mean? When we factor an equation and we find out when y equals 0, we get our x-intercepts. What does that tell us about the equation? And that's what we're going to take a look at today. Okay, so when we're graphing a parabola, and remember that a parabola is just the shape of the graph that a quadratic function makes, and a parabola always has an x squared in it. If it doesn't have x squared, then it's not a parabola. So the points where the graph crosses the x-axis are called the solutions, the zeros, the x-intercepts, or the roots of the parabola. These are the points where y equals 0. So our x-intercepts are when y equals 0, we have to find x. And we have three scenarios when we're graphing quadratic functions. If we have a function or an equation, for example, let's say we have y equals x squared plus 6x plus 10, we won't be able to find factor pairs of 10 that add up to 6 because the only factor pairs of 10 are 1 and 10, and that adds up to 11, and then 2 and 5, which adds up to 7. So this parabola does not have any solution. So here is our coordinate grid, and if we were to graph that parabola, it would not cross the x-axis at all. Crosses the y-axis, but it doesn't cross this x-axis right here. So we would say that this quadratic has no solutions because it has no x-intercepts. We can't factor this. It has no x-intercepts, so there'll be no solution because it cannot be factored. I'll write that in there. The second scenario we can have is what if there's one solution? So that just means that we have a parabola that crosses the x-axis or touches the x-axis in one spot right there. So this means that it has one x-intercept. So what kind of equation would have one x-intercept? Well, let's take the quadratic equation y equals x squared plus 4x plus 4. If we factor that, find the factor pairs, we get x plus 2 times x plus 2. The factor pairs of 4 that add up to 4 are 2 and 2. And to solve this, we get one x-intercept at negative 2, and the other x-intercept is also at negative 2. So this particular quadratic only has one solution because it only crosses the x-axis one time. And finally, the last one is two solutions. So if 0 solutions has no x-intercepts and one solution has one x-intercept, then we can just conclude that two solutions has two x-intercepts. And that's pretty much what we've been working with so far in this unit when we've been doing our factoring. So if we have an equation or a parabola and it crosses the x-axis here and here, what would that look like? So we would have a quadratic that was x squared minus x minus 6, and if we factored that, we would get x minus 3 times x minus plus 2. So our solutions would be a positive 3 and a negative 2. So this point right here would be the point 3, 0. That's one solution. And this point right here would be the point negative 2, 0. If I can make that a negative, there we go. So let's just go back over and look at this so we can have a quadratic that does not cross the x-axis. So that means it has no x-intercepts, so it has 0 solutions. We can have a quadratic that just touches the x-axis in one spot. So that's one x-intercept. So if we have x equals negative 2 and x equals negative 2, it's just going to cross at this point right here, which is negative 2, 0. And then finally, We can have two solutions, which means two x-intercepts. So here's an x-intercept, and here's an x-intercept, and here's a quadratic, an equation that would have two x-intercepts or two solutions. So we're going to graph number 1. We're going to solve the graph y equals x squared plus 2x minus 3. And we're going to solve that first just by finding the factor pairs. So we're looking for the zeros is what we're looking for. So to do that, this is what we've been doing in the past, we can just find the factor pairs of x squared plus 2x minus 3. And the factor pairs of that are x plus 3 and x minus 1. And to find the zeros, we're going to let that equal 0. So that means either x is equal to negative 3 or x is equal to a positive 1. So when we graph this parabola, it should cross the x-axis at negative 3, and it should cross the x-axis at positive 1. So I'm just going to put points there. It should cross right here at negative 3 and at positive 1, and we already know from yesterday's lesson that it has a y-intercept of negative 3. So we're going to go ahead and fill out this chart, and the numbers I picked for x were negative 3, negative 1, 0, 1, and positive 3. Okay, now I'm going to change that last one. I'm going to change those numbers again. Sorry about that. So I'm going to make this negative 3, negative 2, negative 1, 0, and 1. And when I plug negative 3 into the equation x squared plus 2x minus 3, my output is 0. When I plug in negative 2, my output is negative 3. My input is negative 1, my output is negative 4. My input is 0, my output is negative 3. My input is 1, my output is 0. So if we go ahead and graph these points, I'll graph this one first. Negative 3, 0 is right here. We already said that was one of our x-intercepts. And then if we graph negative 2, negative 3, that's this point right here. Then if we go ahead and graph 1, negative 4, that is this point right here. And then we have 0, negative 3 is this point right here. And then finally we have 1, 0, which is this point right here. So I'm going to go ahead and put that parabola in there. So where does this parabola cross the x-axis? It should cross the x-axis at negative 3 and positive 1, and it does. It crosses at negative 3 and at positive 1. So those are solutions, the x-intercepts or the zeros. So we're going to write those x-intercepts up here. The first x-intercept is negative 3, 0, and the second x-intercept is 1, 0. So how do the x-intercepts compare to the factor form? Well, they are the same. They are the solutions to x plus 3 equals 0 and x minus 1 equals 0. So again from yesterday, what was the vertex? And the vertex is the highest or the lowest point. So the vertex in this case is our lowest point, so that makes it a minimum. And that vertex is the point negative 1, negative 4. Our axis of symmetry has to go through the vertex. So here is our axis of symmetry right there. And our axis of symmetry goes to the x value of the vertex. So our axis of symmetry is x equals negative 1. And this x equals negative 1, this is the halfway point. So that's where the parabola switches directions, and it's halfway between negative 3 and positive 1. That's our halfway point. So we know how to take an equation and create a parabola. In the second part, we're going to take this parabola and we're going to create the equation. So now we need to be able to write an equation from looking at the graph. And we've been finding zeros on our graphs, and we have seen the connection between the solution and the equations to the graph. So we just need to find what our x-intercepts are. And this x-intercept over here is negative 1, 0. And the x-intercept on this side is 3, 0. So where did these come from? And let's write them over here. So our x-intercepts, we said were -1 and 0 and 3 and 0. Our vertex is right here. That's the lowest point, and this vertex is 1, 4. The axis of symmetry has to go through the vertex. So our axis of symmetry has to be the same as the x value of the vertex, and that's x equals 1. And since this is opening up, it's a minimum. The vertex is the minimum. So how do we take this information so that we can write a quadratic equation for this? So we know that this is the solution. Let's see, so for our first x-intercept, we got x equals -1. And if we remember, that was the opposite of our solution. So if I write x plus 1 equals 0, x equals -1 is the solution to this. So we're just working backwards. This is negative, so this needs to be positive. If I did the same thing with this one, we had x equals 3, so that's the solution. Again, we're thinking opposite to x minus 3 equals 0. So these two binomials will created the x-intercepts. So if we have x plus 1, if we multiply those together, we should get our quadratic. So if we do x plus 1 times x minus 3, that's our y equals. If we factor this, we get x squared minus 2x minus 3 equals y. So this equation is the equation that matches this parabola right here. So in case you're still just a little bit confused, if we factored this parabola, we'll just go backwards again, we would get x plus 1 and x minus 3 equals 0. This is going to give us x equals -1, which is right here, and this is going to give us x equals +3, which is right here, which are our x-intercepts right here and right here. Okay, now it's your turn. So using your calculator or a piece of graph paper, you need to sketch the graph of the following quadratic. So you're going to sketch this graph. What is the vertex? Is it going to be the lowest point or the highest point? So you're going to have to graph this, plug in some points, and find the vertex. And using the same quadratic from number 1, how many solutions does the parabola have? So you're going to need to factor x squared plus 6x plus 9 equals 0. You're going to have to factor that. And so your answer is either going to be 1 solution, 2 solutions, or 0 solutions. Okay, make sure you enter your answers on the Google form, and if you have any questions, you can ask those as well.